Hi everyone, today we are going to talk about hyperbolas. So the formal definition of a hyperbola is a set of points represented by these two curves where if you take the difference between D1 and D2, which is just the distance between your point and either of your foci, that difference or the absolute value of that distance is always going to be constant. So it's kind of similar to the definition of an ellipse, except for an ellipse, it was the sum of those distances was constant. So here's the difference of these two distances is always going to be constant. So the standard form of hyperbola also looks similar to that of an ellipse, except a few things that you'll notice are very, very different. So here you can see that we actually have a difference instead of a sum, so that's extremely important. And another thing that's extremely important is how we differentiate between horizontal and vertical. So for this one, if you look at the differences between your horizontal equation and your vertical equation, the only thing that changes is where the x and the y terms are. So if your x terms come first, it's going to be a horizontal hyperbola. If your y terms come first, it's going to be a vertical hyperbola. Now you need to differentiate this from the ellipse standard equations, because for the ellipse we were always looking for the larger denominator. The larger denominator told us whether it was horizontal or vertical. For hyperbolas, it's always going to be which term comes first. Now, a few things that you'll notice are still the same. H and K is still going to be the center of our hyperbola. A is going to be the distance between your center and your vertices. So if you have a horizontal ellipse, A is a horizontal value. If you have a vertical ellipse, A is a vertical value. B is going to come into play when we talk about the asymptotes of our hyperbola. So hyperbolas actually have asymptotes, and we will talk about those equations, but we'll talk about those in a minute. And then C is going to be the distance from the center to the foci. And of course, those are going to fall in the same direction as your, essentially what your major axis. So the same way that your A value moves. Now, another thing that's a little bit different than the ellipse equation is the way that you find C. So for a hyperbola, C squared equals A squared plus B squared. So that's going to be a really important thing that you keep separate from ellipse as well, which was A squared minus B squared. All right, so let's give this a try. Here they would like us to find the standard form of the hyperbola that has vertices at 0, 2, and 4, 2. Let's just sketch out a really, really rough sketch here. So we have 0, 2, so it'd be here, and 4, 2, so it'd be here. So since our vertices are horizontal, I know that our hyperbolas are going to also be horizontal. So I'm looking for something like this. X minus h squared over a squared equals y minus k squared. Oops, sorry, not equals. That should be a minus sign. Over b squared equals 1. So when I am given the vertices, I can find the center by finding the exact midpoint between your two vertices. So I can see that our center is going to be right here at 2, 2, which means h is 2 and k is 2. And also I can find the distance between the center and either of my vertices, and that's going to be my a value. So a is going to equal 2. So I already know H, K, and A. I still need to find B, so let's look at the other piece of information they give us. They tell us that the foci are at -1, 2, and 5, 2. So I can use the foci to help us find that C value. So I can see the distance from the center to my foci is 3, so that's going to be the C value. Now if I know C and A, I can use the equation C squared equals A squared plus B squared, and I can find that B value. So I can say 9 equals 4 plus B squared. So I know that B is going to be the square root of 5. So I now know H, K, A, and B, so I now have enough information to make the equation. We can say x minus 2 squared over A squared, so it's going to be 4, minus y minus k squared over b squared. Square root of 5 squared is just 5. And then we say equals 1. There you have it. All right, go ahead and pause the video and see if you can give this problem a try. Okay, so the information from this problem implied that we have a vertical hyperbola because the vertices are right on top of each other. So from that, we were able to find the center and our a value. We were also given the foci, which allowed us to find the c value, the distance from the center to your foci. And then since we have a and c, we can find our b value. So then plug it in. Remember, this time it's going to be y minus k squared first because it is a vertical ellipse. Or sorry, hyperbola. All right, so now we're going to talk about the asymptotes. Now this picture, or these two graphs, can look a little bit overwhelming, but here's what I would like you guys to focus on. We know that the a value is the distance from our center to your vertices. So this is going to be a. Now that b value comes into play to help us make this little rectangle, which can help guide our asymptote. So the a value is the distance from the center to our vertices. The b value is going to be the distance from our center up and our center down for what I'll call our guideline rectangle. So we start our center, we go up b and down b, or if it's vertical, we go right b, left b. Now if you create a rectangle using those 4 guidelines, you can find the equations of your asymptotes by simply creating the line that goes through the opposite corners of those rectangles. Now, you might notice that there's also these formulas for the asymptotes, but I'd rather you understand where they come from. So let's start by talking about this slope part. This slope simply comes from the rise over run. So for a horizontal equation, the rise of our slope is going to be b, the run is a, because this distance is a. So the slope is plus or minus b over a. For the vertical asymptotes, this time a represents rise and b represents the run. So really all you have to do is figure out, is my a going to be a vertical or a horizontal movement, because that will determine whether the slope is b over a or a over b. From there, you're simply going to use point slope equation. This is just a rewrite of point slope equation, which is y minus y1 equals m times x minus x1. And you can use the center as your given point because both asymptotes will always go through the center. The other thing I want you to notice is that your asymptotes will have opposite slopes. They might look very different. They might have very different y-intercepts, but they will certainly have opposite slopes and they will both always go through the center. All right, so let's give this one a try. We're going to sketch this hyperbola, and we're also going to be, we'll write the equation for the slope, or we'll write the equation for the asymptotes as well. And we're going to graph our asymptotes as well too. So I'm looking at this and I know that it's not quite in standard form, so I'm going to have to first divide both sides by 16. And I'll have x squared over 4 minus y squared over 16 equals 1. So I know that this hyperbola is horizontal because the a value comes first. And I know that my a value, or I'm sorry, because my x term comes first. I know that a is going to be 2, and I know that b is going to be 4. And we can actually find our c value. So c is just going to be the square root of 20. So remember, c squared equals a squared plus b squared. So c is going to equal the square root of 20, which is 2 root 5. Okay, so let's start by sketching out what we know so far. I can see that our center is at 0, 0. Since it's horizontal, I'm going to go to the right 2 and to the left 2. That's my a value, and that's where my vertices are going to go. My c value is 2 root 5. So I'm just going to have a rough estimate for where that would be. I know that 2 root 5 is somewhere between 4 and 5, because square root of 20 is somewhere between the square root of 16 and the square root of 25. So I can give myself a couple more dashes, and I know that it's going to be right between 4 and 5. So those are my foci, but now we're going to want to also make our asymptotes. So how we can do this with our graph is we can make our little guideline. So we know that we're going to have a guideline here and here, and then I'm going to go up 4 and down 4 because that's our B value. And if I make a rectangle that hits all of those guidelines, so it goes right 2, left 2, up 4, and down 4, I know that our asymptotes are going to go through the opposite corners and through the center. So that's one of our asymptotes. That's our other asymptote. So our asymptotes will help us to guide the shape of our graph. So we can see that it's going to go out wide like this. So they help us to make a more accurate graph. So let's see now if we can actually make the equations of our asymptotes. So if I look at what the slope would be, I can see that the slope is going to be rise over run, which in this case is going to be B over A. And the rise over run in this case is 4 over 2. So our slope is going to be plus or minus 2. I see that both of them go through the center, which is actually also the y-intercept. I can see that our y-intercept is at 0, 0. So our slopes are actually quite, or our equations are quite simple to make. It's just y equals 2x and y equals negative 2x. Those are the equations of our asymptotes. But once again, you can always, you can use either the formula we learned, you just have to decide if it's B over A or A over B, or you can always sketch out these little rectangular guidelines to help you determine where your asymptote will fall, and then you can look at your graph to make the equation. Either way is fine. All right, so go ahead and pause the video and give this one a try. Okay, so this one, we have a horizontal or a vertical hyperbola, and I know this because the y term comes first. So if we have a vertical hyperbola, that means that the a value is now going to represent vertical motion, which is going to be the rise of our slope. So in this case, the slope is actually a over b. It still goes through 0, 0, so that's going to be the y-intercept of both of our asymptotes. So these are the equations of the two asymptotes. I know that a is 3 and b is 2, so you can also create that guideline triangle by going up 3, down 3, right 2, left 2. And I know that the c value is root 13, which will fall between 3 and 4. So you should always at least plot it between the correct two integers. And from here we can also find the coordinates of our vertices and our foci. All right, so now let's try another one together. Here you can see that we have an equation that is not in standard form. So we're going to follow that same process that we did with ellipses. We're going to group our terms, and we're going to be completing the square twice, once for x and once for y, if necessary. So I'm going to group my x terms and factor out the 4. So 4 times x squared plus 2x plus something. And then we have minus 3y squared. That's just a single monomial, so we're good to go there. And I'm going to move negative 16 to the other side. And now I'm going to complete the square. For our x trinomial, we're going to add 1, but we're actually adding 4 times 1, so we're actually adding 4. So now we can factor that out. And here we have negative 12. Please don't forget to add 4 to the right side of your equation. And now to put it into standard form, we're going to divide both sides by negative 12, which will actually turn our y term into the lead expression, and then our x term will become the negative one, so it will come second. So x plus 1 squared over 3. Okay, so from here, I can see that we have a vertical. Our a value is going to be 2, our b value is going to be the square root of 3, and our c value is going to be the square root of 7. Our center is going to be negative 1, 0. So for this graph, for the asymptotes, There's two different ways we can do it. We can graph it and then look at our graph to make the equations, or we can try making the equations beforehand. So if we do that, I do want to point out that this time our a value is going to be vertical. So if we want to find the slope of our asymptote, it's going to be plus or minus a over b, which is going to be plus or minus 2 over root 3. I know that our asymptotes will also both go through the center, which is at -1, 0. So we're going to have to use point slope form to find this. So we have y minus y1 equals m, so we'll do 1 for the positive, times x minus x1, and then y minus y1, which is 0, equals the other m, which is the negative version, times x minus x1. So these are going to be the two asymptotes. So let's sketch a graph. Okay, let's start with our center. Our center is at 0, -1. I know that I'm going to go up 2 and down 2 to find my vertices, which are going to be at -1, 2, and -1, -2. I know that my foci are going to be up and down by root 7 from the center. So I'm going to start at my center, and I'm going to add root 7 to my y value, and then I'm going to subtract root 7 from my y value. So they're going to be at -1 square root of 7 and -1 negative square root of 7. So we know that the square root of 7 is a little bit less than 3, so our asymptotes are going to, our foci are going to be here and here. And now we can also, I like to make the little guideline box to graph. I know that the square root of 3 for my b value is a little bit less than 2, so I'm going to go a little less than 2 to the right, a little less than 2 to the left, and I can make my little guideline rectangle, which will help me to graph the asymptotes. So our asymptotes are going to look like this and like this. So remember, they go through the opposite corners of our rectangle and right through the center. And that will allow us to kind of see the more broad shape of our hyperbola. And there you have it. So from this, we have, once again, found the vertices, we found the foci, and we found the equations of the asymptote, as well as the center. All right, go ahead and pause the video and give this one a try. Okay, so for this problem, the first thing you need to do is to put it into standard form. Just be careful because here, when you complete the square for your y trinomial, we are actually subtracting 4 from both sides. Put it into standard form, and here's what you have. So we have a horizontal hyperbola because x comes first. The center is at 0, +1. A is 2, b is 3, c is the square root of 13. So this time, the slope of our asymptotes is going to be b over a, because this time a is horizontal. So our slope is going to be plus or minus 3 over 2. And it actually goes through the center, which is a y-intercept. So our y-intercept is 1, which makes these asymptote equations really easy to make. We do have vertices at 2, 1, and -2, 1, and then we have foci at square root of 13, 1, and negative square root of 13, 1. And here's what your graph should look like, and make sure you have all of the information included. Okay, so let's try one more type of problem together. Here we're going to try to make a standard form of a hyperbola with just by being given the vertices and the equations of the asymptotes. So the vertices here will tell us what our a value is. It can also help us to find our center, and it can oftentimes be useful just to plot out what we have. So our vertices are at 3, -5. So we have a vertex here, and then we have a vertex at 3, 1. So I can see that the exact middle of that, or the midpoint of that, is going to be at 3, -2. So I now know h and k, which are really important. I can also see that our a value, which is the distance from the center to our vertices, I can see that a is equal to 3, which is also a crucial part of our equation. However, there's still one more part that we need to know. We need to know our b value. So I can find the b value by looking at the slopes of our asymptotes. So if we have hyperbolas that look like this, since they are vertical, the slope of our asymptotes, which looks something like this, are going to be a over b, because now a represents that rise. So the slopes are going to be plus or minus a over b. Well, we know that the slope is 2, so 2 is going to be a, which is 3, over b. So I can use this to solve for b. I can say 2b equals 3, so b equals 3 over 2. So that is going to be our b value. It's a little bit weird to have a b value that's a fraction, but it's completely legal. So from here we have everything that we need. We have our a value, we have h and k, and we have b. And once again, we were able to use the slope of our asymptotes to help us find that b value. So now all we need to do is create our equation. So we can say y minus k squared. So remember, y has to come first because it is a vertical asymptote, or vertical hyperbola, over, and then we're going to do a squared, so a squared is 9, minus x minus h squared over b squared. We'll just say over 9 over 4. And we can leave it like that. That's completely fine in this case to have a complex rational expression equals 1. And this is the equation of our hyperbola. All right, here's the last example. Go ahead and pause the video and give this last one a try. Okay, so for this problem, we were given the vertices again and the asymptotes. So we could see, using the vertices, we could find the exact midpoint of that to find our center, which is hk. The distance from our center to our vertices is 3, so that's our a value. Since our vertices are lined up horizontally, I know that our x value should come first. It is a horizontal hyperbola. And since it is horizontal, this time when we do rise over run, it's going to be b over a. So we know that our slopes are going to be plus or minus 2 over 3 because we're given the two equations. So we can say 2 over 3 equals b over a, 2 over 3 equals b over 3, which is our a value, allowing us to find that b is 2. So you should end up with x minus 6 squared over 9 minus y minus 2 squared over 4 equals 1. All right, that is all for today. Thank you so much for watching.